Good day, learners! Welcome to our video lesson in Mathematics 10. We are now on the second week of third quarter with the lesson Solving Problems Involving Permutation. At the end of this lesson, learners are expected to solve problems involving permutation. But before that, let us first define permutation. When we say permutation, that is a collection or a combination of objects from a set where the order or the arrangement of the chosen objects does matter. In other words, a permutation is an arrangement of the object in a definite order. Here are some questions that will help us to decide which techniques or formula should be applied, and it is also easier for us to solve the given problem. First, are the objects all distinct? Second, how many objects are there in all? Third, how many objects are we asked to place into an ordering? 4. Are there any restriction on the objects or on the ordering? Example, how many three-letter words with or without meaning can be formed out of the letters of the word swing when repetition of the letters is not allowed? Based on the given problem, we are going to form three-letter word with or without meaning from the word swing. So n is equal to 5, since there are 5 letters of the word swing. R is equal to 3, since we use only 3 letters from the word swing. So to solve the problem, we use the formula of permutation P of nr equals n factorial divided by the quantity of n minus r factorial. And then substitute what are the given. P of 3 is equal to 5 factorial divided by 5 minus 3 factorial. Then evaluate. P of 3 equals 5 factorial divided by 5 minus 3 factorial is 2 factorial. Simplify. P of 3 equals 5 factorial is 5 times 4 times 3 times 2 times 1 divided by the 2 factorial, which is 2 times 1. Then let us cancel 2 times 1. Then multiply the remaining factors, 5 times 4 times 3, and that is equal to 60. Therefore, there are 60 possible three-letter words to form from the word swing. Next example, you have been asked to judge in a mathematics poster making contest with 15 entries. In how many ways can you assign first, second, and third place? In this example, n is equal to 15 because there are 15 entries in mathematics poster making contest, and r is equal to 3 since we are only arranged them as a first, second, and third place. So to solve the problem, we use the formula of permutation P of nr equals n factorial divided by the quantity of n minus r factorial. Then substitute what are the given to the formula. So P of 3 is equal to 15 factorial divided by the quantity of 15 minus 3 factorial. Then after that, evaluate. P of 3 is equal to 15 factorial divided by 12 factorial. P of 3 is equal to 15 factorial, which is equal to 15 times 14 times 13 times 12 factorial divided by 12 factorial. Then cancel 12 factorial. Then after that, multiply the remaining factors, which are 15, 14, and 13. So P of 3 is equal to 2,730. Therefore, there are 2,730 ways to assign the 15 entries as a first, second, and third place. Another example, there are 8 basketball teams competing for the top 4 standings in order to move up to the semifinals. Find the number of possible rankings of the 4 top teams. So our n is equal to 8 because there are 8 basketball teams. R is equal to 4 because we need to have the top 4 standings in order to move up to the semifinals. So to solve the problem, we use again the formula of permutation P of nr is equal to n factorial divided by the quantity of n minus r factorial. And then substitute what are the given to the formula. So P of 8, 4 equals 8 factorial divided by 8 minus 4 factorial. Then evaluate and simplify. So we have P of 8, 4 equals 8 times 7 times 6 times 5 times 4 factorial divided by 4 factorial. Cancelled out 4 factorial. So we have now P of 8, 4 equals 1,680. Therefore, there are 1,680 possible ways for the 4 top teams. Number 4. How many ways can the letter of the word committee be arranged? The problem is an example of distinguishable permutation, meaning having the same objects. So we use the formula of distinguishable permutation. The word committee has 9 letters, so our n is equal to 9. Then let us determine the alike objects or letters. So our n sub 1 or letter m is equal to 2, since there are 2 m on the word committee. N sub 2 or the letter t is equal to 2, since there are 2 t on the word committee. And n sub 3 or the letter e is equal to 2, since there are 2 letter e on the word committee. So to solve the problem, we use the distinguishable formula, which is P equals n factorial divided by n sub 1 factorial times n sub 2 factorial times n sub 3 factorial. Then after that, substitute. So we have P equals 9 factorial divided by 2 factorial times 2 factorial times 2 factorial. And then evaluate and simplify. So we have 9 factorial is 326,880. And 2 factorial times 2 factorial times 2 factorial is equal to 8. Then divide 326,880 divided by 8. And the answer is 60,480. Thus, 60,480 ways that the word committee arrange. Another example, find the number of different ways that a family of 6 can be seated around a circular table with 6 chairs. This problem involves circular permutation. So in this example, our n is equal to 6. So to solve the problem, we use the circular permutation formula, which is P equals the quantity of n minus 1 factorial. Then substitute, P is equal to the quantity of 6 minus 1 factorial. Simplify and evaluate. P is equal to 5 factorial. And 5 factorial is 5 times 4 times 3 times 2 times 1. So the answer is 120. Therefore, there are 120 ways that a family of 6 can be seated around a circular table with 6 chairs. Alright, I hope you have learned from this video lesson. Thank you for watching. God bless and have a good day. This is Irene A. Eugenio saying goodbye.